All right, let's consider the following graph of a function y equals f of x. We can see just by looking that if we look at the first part of this graph, from here all the way up to about here, we can call these points A and B, we can see that the graph is rising. And then from B down to C, the graph is falling. And then from C up to D, it is rising again. And we actually, if we call these lowercase a, if we call the x values lowercase a, b, c, and d, we have terminology. Instead of just rising and falling, we can call these parts of the graph increasing and decreasing. So if we look from A to B on that interval, we can see that the function is increasing, meaning it is moving upwards. The function values are getting higher as the x values get higher. And then on the next interval from B to C, that function is decreasing. And then the next interval from C to D, it is increasing again. I don't think it's very difficult to have an intuitive sense of when a function is increasing and increasing again. But I want to give you an explicit definition just so that we can have a mathematical, a rigorous definition here for the terms increasing and decreasing. All right, here we go. A function f is called increasing on an interval. We can call that interval I. If f of x sub 1 is less than f of x sub 2, whenever x sub 1 is less than x sub 2 in I. So within an interval, we can say the function is increasing so long as when we look at two different x values, x sub 1 and x sub 2, the x value that is larger has a function value that's larger than the x value that is smaller. So the function value here, f of x2, is larger than the function value of the other one, f of x1. What this means is that if we have our function that flatlines for a bit and then increases afterwards, we can't say that it's increasing on this whole interval, because when it is flat, that is not increasing, that is remaining constant. So this definition does not allow for a function to go flat for a bit if we want to say that it is increasing on that interval. Similarly, we call the function decreasing on an interval if f of x sub 1 is greater than f of x sub 2 whenever x sub 1 is less than x sub 2 in I. So I think this isn't too terribly surprising. If we have two x values and the first one has a larger function value and the second one has a smaller function value, and that's true for all pairs of function values in that interval, that means that it is decreasing in that interval. The reason I wanted to talk about this briefly is because as we move into calculus topics, we're going to learn about something called the derivative of a function, and that is going to be an excellent tool that's going to tell us when a function is increasing, when it's decreasing, and when we might have maximum and minimum values, meaning we're reaching peaks and valleys. And these are very important when a function is representative of something in the real world. Thinking about profit functions, if we have some function that is a profit function and it gives us a graph that's something like this, well, who doesn't want to maximize profit? We want to be able to figure out exactly where this maximum value comes from. So it's important to know when the function is increasing and when the function is decreasing, because that maximum value happens in between those intervals. So we just want these definitions because these concepts are going to be very useful moving forward into calculus concepts.